Alright, I've seen a lot of people on the internet talking about the eclipse that's going to happen, and many people don't understand how it works or claim that it can't work if the Earth is a sphere. So I'm going to try to show you a couple of visuals to help explain what's going to happen during the eclipse and why it's going to happen that way. First, here's a reference for the size of the sun compared to the moon and the Earth. The sun's diameter is about 400 times longer than the moon's diameter and about 100 times longer than the Earth's diameter. And if we scale down the size of the sun to this, we can see how far it is from the Earth and the moon. You can also see how close the Earth and the moon are compared to how far away the sun is. Again, the diameter of the sun is about 400 times longer than the diameter of the moon, but it's also about 400 times further from the Earth. So that's why when you look at the sky and you see the sun and the moon, they look to be about the same size. The next thing we're going to look at is the rotation of the Earth and the orbit of the moon. So in this diagram, the N here represents the North Pole, or the north side of the Earth, and this black dot here is just somebody sitting on this side of the Earth coming to watch the eclipse. So from their perspective here, this W is west and this E is east. Now since the Earth rotates once per day, right, the moon takes almost a month to orbit. So you'll see the moon traveling across the sky from east to west, very similarly to how the sun does, but the moon just travels slightly slower across the sky. When the eclipse happens, though, the shadow from the moon is going to travel across the Earth from west to east. And this is a little bit confusing because you watch it go from east to west, but the reason it does that is because the Earth is rotating at only about 1,000 miles per hour at the equator, and then that gets less as you get closer to either pole on the Earth, right? But the moon is orbiting at around 2,300 miles per hour. So the shadow that it casts as well is going to move even faster than that. So the shadow is going to end up traveling across the Earth from west to east at least 1,300 miles per hour. The other thing that people are getting confused about is the path of totality, which is where the moon completely eclipses the sun, resulting in a total blackout. The path of totality ends up being only around 70 miles wide, but the moon is around 2,000 miles wide. And some of the people's arguments are, if something's casting a shadow, the shadow is always bigger than the thing casting the shadow. But that's not necessarily true. Say you have this flashlight right here, and you have light being emitted from this entire yellow bar here, right? And then you have this little blue circle here that's blocking the light, all right? This black area right here, right behind it, that's all of the area that's going to be in total darkness from this light, because this is the area that's being totally blocked out. These gray areas will be partially blocked, so they will be dimmer than the rest of the area, but they won't be completely blocked by the blue circle. This black area is like the path of totality, right? When it hits this orange area right here, that little tiny section that's touching is like the path of totality, because that's the only spot that's being completely blocked from the sun by the moon, right? You're going to have a lot of area that has that's partially blocked, right? But a very, very small portion that's actually the path of totality. So that's why there's only that small section there. Like, it actually is casting a very big shadow, but only a very small section of it is a total blackout. Hopefully this helps clear things up a bit.